Day to all my students. Today we are here to continue on the chapter Carbon Compounds part 4, where teacher will discuss about another hydrocarbon which is alkene. So in part 2 and part 3, teacher discussed regarding alkane, the physical properties, the general formula, physical properties and also chemical properties of alkane. Now in this video, I am going to introduce to you alkene, another example of hydrocarbon. Now let's start. So alkane is one example of unsaturated hydrocarbon. You should have known this because I have introduced to you in part 1 example of hydrocarbons and types of hydrocarbons, which is saturated alkane, unsaturated alkene. So alkene is an hydrocarbon. So can you see here hydrocarbons which are unsaturated? You might be wondering how alkane becomes saturated and alkene became unsaturated. Unsaturated is because it has carbon double bond. Okay, so because the presence of carbon double bond, existing, for instance, teacher just roughly draw here carbon. So this is example of alkane, namely propane. Okay, propane. So this is how we draw in our before this example, which is alkane. But here you only see single bond amongst carbon and hydrogen atom. But when you are drawing alkene, you have one extra double bond. You have one extra bond. And please remember, in our previous video of part 3, teacher have emphasized that carbon can only share 4. So that is the reason why you must eliminate one bond from carbon. Why? Because you already have 2 bonds here. So see, 1, 2, 3, 4. So here will be eliminated. Now 1, 2, 3, 4, 5. So this is wrong. Why? Because carbon can only share maximum 4 electron thanks to the electron arrangement of 2.4. Okay, so that's the reason why you will be surprised to find it is no atoms shared here. And if you count, you will find 1, 2, 3, 4. And please remember, the double bonds is only between carbon atom. So it is important to emphasize the double bond is between carbon atoms only. Okay, so because double bond between carbon and hydrogen atom does not exist. Alright. Okay, now so let's go to general formula of alkene. General formula of alkene is CnH2n. So compared to alkene, you will find that the amount of molecule or amount of atom in the molecule of alkene, amount of atom is lesser compared to amount of atom in alkane. For instance, okay, so just teacher give you one example. For instance, if we compare C to H6, this is ethane, with the same amount of carbon C to H4 for ethene. Okay, this is alkane, you will find that the amount of atoms is lesser in alkene compared to alkane, thanks to the presence of carbon double bond. Right? Okay, so you understand better when I'm explaining regarding the naming of alkenes and also their structural formula. Now, how do you name alkenes? And when you are naming alkenes, again you have to remember part 2 video where I introduced you to the prefix of the alkane, where when you have C2, the molecule, the name of the molecule will start with eth. If C3 starts with pro. Okay, so these are the prefix that I have explained to you in part 2. So you can go back to part 2 and watch again. So let's go to how are we going to name alkene molecules. So the first member of alkene molecule is ethene. C2H4. Second member propene. C3H6. Let me write this. Butene. Pentene. Hexene. Heptene. Octene. Nonene. And last, decene. C10. Decene. C10. H20. Okay, so now after this you will find that behind each of the prefix it ends with E and E. Why? For alkane, just say for alkane we have ethane, Ne, alkane, A and E. So if we are talking about alkene, it will be ethene. Why? Because E and E. So this is how you know. Just by knowing the prefix and the last three alphabets, whether E and E or A and E, you can identify whether it's an alkene or alkane. Now, another thing I would like to highlight here is you might be wondering, in alkane, the first member was C1. Okay, in alkane, the first member was C1. But here, I am telling you that the first member of alkene is C2. This is because, but not C1. Please remember, methane does not exist. Why? Let's go back to here. In order to have carbon-carbon double bond, the minimum amount of carbon that you need is 2 carbons, correct? So that is the reason why the first member of alkene is ethene. Methane does not exist. Another mistakes that students do is when teachers say, for instance, when teachers say second member of alkane, you know, ethane. When teachers say second member of homologous series ethane, second member of homologous series alkane. Ethane will be the answer. But when teachers say second member of alkene, it is propene. Please remember that. Majority of students make mistakes here. When I refer to third member of alkene homologous series, you must count 1, 2, 3. You'll be surprised to find the third member of alkene is actually butene. So this is where you all make mistakes. So I would like to highlight here. Okay, so prefix I think should be okay. Now let's go to physical properties. Okay, so physical properties. In our next video, teacher will continue on chemical properties. And I would like to highlight here that chemical properties for alkane is much lesser compared to alkene. Again, because of the double bond. Okay, but it's okay. The one we'll do on next part 5. Now, let's go to physical properties of alkene. Melting and boiling point. Another thing that you need to understand is, again, alkane and alkene hydrocarbons, and they are covalent compounds. So when we are discussing physical properties, you must remember that we are indeed discussing regarding covalent compounds. So that is the reason why melting and boiling point for alkene is relatively low, but gradually increase because more carbon atoms. Okay, so the explanation is same like what teacher did in part 2 videos. Why melting and boiling point of alkane increases gradually when going down the homologous series. Okay, so gradually increase because more carbon atoms, force of attraction, van der Waals force of attraction increase. So that is the reason why melting and boiling point increases. So you will know that ethene is a gas, propene is a gas, butene is a gas, and pentene onwards up to decene, they are liquids, thanks to the increase of melting and boiling point. Now, density. Of course, melting and boiling point have very much connected with density. So, density increases when from ethene up to decene, you will find that the density increases. Again, because more carbon atoms. Okay, so molecule become bigger. Okay, so molecules become bigger. So that is the reason why we have more force of attraction, okay, between the carbon atoms. You can even say van der Waals force of attraction between carbon atoms, okay, between the atoms mainly. So that is the reason why density increases. Solubility, of course, don't worry. Up from ethene up to decene, none of them are soluble in water, but they are soluble in organic compound. Okay, not soluble in water, soluble in organic compound. Okay, soluble in organic compound. And again, if you remember that covalent compound does not conduct electricity, it's easy for you to say that none of the alkene homologous series members can conduct electricity in any state. Why? Thanks to them being a covalent compound. So, they cannot conduct electricity. Because they are molecules. Okay? Just because they are molecules and they don't have free moving ions, they can't conduct electricity. Alkenes and alkanes can't conduct electricity because they are molecules and covalent compounds. No free moving ion. You can even also use that. Okay, so in our part 5 video, teacher will concentrate on chemical properties of alkenes. Get ready, it is going to be a very long video because alkenes are more reactive compared to alkanes. Okay, so teacher will explain to you why in part 5 video. Till then, thank you for watching. See you all.